Welcome, fans. In this video, I'll be talking about bubble sort. I'm going to give you an explanation and an example of how it works. So we will be doing bubble sort. So bubble sort is one of the simplest sorting algorithms used to arrange elements in a list in a specific order, typically ascending or descending. So use to arrange elements in order either ascending or descending. So it's a simple, compared to others, this would be a simple algorithm. So this one is not efficient for large data set. But it's good for educational purposes. So how does it work? How the algorithm works? So it works by repeatedly stepping through the list to be sorted. So it compares adjacent terms. Swapping them if in wrong order. This is done until the whole list is ordered. Order or sorted. So it gets his name because smaller elements bubble to the top of the list. Now we're gonna say steps of bubble sort. First, start at beginning of list. Second, compare first and second element. If first is greater than second, swap. Swap the elements. Third, move to the next two pairs and repeat step 2. That means that you have to compare and swap if necessary. Compare and swap if necessary. Now we'll do step 4. Continue this process until the end of the list. Number 5, repeat steps 1 to 4 again for the whole list except for the last element since it is in the right place, right order place. So now continue doing step 5 until no more swaps are needed. Email full complete pass through. Now we're gonna do an example. So the unsorted list is as follows: 5, 2, 9, 1, 5, 6. So we're gonna do pass 1. So we're gonna compare and swap the first two elements. So that's gonna be, so we're gonna write 5, 2, 9, 1, 5, and 6. That will become, so we're gonna concentrate on these two, compare them. 5 is higher, so we move it to 2 and 2 back. So we're gonna swap, and then this is gonna become 2, 5, 9, 1, 5, and 6. So we did a swap here. So now let's write what we have. 2, 5, 9, 1, 5, and 6. Now we're gonna do 5 and 9. So that's in the right place. So no swap. Now let's go to the next adjacent. I'm gonna do 9 and 1. Now we can swap. So we're gonna do 2, 5, 1, and 9, 5, and 6. So we do a swap. So we did 1 and 9. Now we're gonna do 9 and 5. So we're gonna do another swap. Let's do it 2, 5, 1, 5, 9, 6. So that's the swap. And for the last two elements, we're gonna do 2, 5, 1, 9, and 6. So we're gonna concentrate on the last two. That's gonna be 2, 5, 1, 6, and 9. So that finished pass 1. So now this one is already in order. So we're not gonna concentrate that on the next step, next pass. So right now we're on 2, 5, 1, 6, 9. Okay, so pass 2. So right now we're in 2, 5, 1. Okay, what is it? 2, 5, 1, 6, and 9. 6 and 9. Okay, so we're gonna concentrate on the first two. 2, 5, that is correct, so no swap. Now we're gonna go to the next one. 2, 5, 1, 6, and 9. We're gonna go 5 and 1. We do swap. So that's gonna be 2, 5, 6. Sorry, 2, 5. 2, 1, 5, 6, and so that's swap. And actually 9 and 5. So 5 and 9. I forgot to leave the 5 here. 5 and 9. So that will be 5. 5, 6, 9, yes. So it would be 5 here, 5 here, 5 here. Sorry about that. And then, okay, so now let's go to the next one. Let's be more careful. Okay, so 2, 5, 1, 5, 5, 6, and 9. Okay, so now we did 5 and 1. So this will become here instead of 5 and 1, this is gonna be 1 and 5. One and five, okay. 1, 2, 1, 5, 5, 6, 9, yes, okay. So we did 5 and 1, so this is good. So now we're gonna do 5 and 5, so no swap. The next one, 2, 1, 5, 5, 6, and 9. So we look at 5, 5 and 6. So that's in order, so no swap. So the next one, we don't need to compare 6 and 9 because they're already in order. Okay. Okay, so now we're gonna do pass 3. Okay, so we have 2, 1, 5, 5, 6, 9. 2, 1, 5, 5, 6, 9. Okay. We're gonna concentrate on these two now. Okay, so that will become, so we need a swap there because so we're gonna do 1, 2, 5, 5, 6, 9. So we did a swap. Okay, so now we're gonna do 1, 2, 5, 5, 6, 9. We're gonna do 2 and 5. So no swap. Now 5 and 5, we don't need, it's a no swap. And we don't need to do more financing because they're already in order. So now it means it went through a full pass and no more swaps. The list is in order 1, 2, 5, 5, 6, 9. So list in order. So no more swapping, no more swapping. So we can say done. Sorry about the previous that I missed the number 5 there because when I did it here I forgot to put this one here. So make sure you look at it. So I'm gonna give you some characteristics of bubble sort, but we're gonna go in another video. I'm gonna go into more in depth about it. So some of the characteristics of bubble sort. We can say time complexity, it's O n square, or the worst and average cases. Where n is the number of elements. So this is not good for large datasets. Number two, space complexity. Space complexity, that's going to be O1. That means that it's an in-place sorting algorithm, in-place sorting algorithm. Now we're going to talk about the stability. So the stability, it is a stable sort. That means that it preserves the relative order of equal elements. It preserves the relative order of equal elements. Now we're going to talk about adaptability. It is adaptive. Adaptive if a flag exists to stop early if the list is sorted. So in summary, while bubble sort is not suitable for large datasets due to its high time complexity, it serves as a great introduction to sorting concepts and algorithm thinking. So remember, this here is not good for high, not okay for large datasets. So thank you for watching. Please subscribe, my friends.